Hey Lily, I thought it would just be easier if I recorded something to show you what I think they're showing. I really don't blame you for being confused. The reason I gave you the table that looks like this, but I gave you it in this format, was to fill it out because it's exactly what I want. It's already organized in a reasonable order. Um, this recording in the lab notebook is really confusing, I agree, because they put the control first, which is your DH2O, 0% glucose. But then they jump to 40%, which is the highest, and then they go back down to 5. So it either makes sense to go 40 all the way down to the control, or the control up to control 5% up to 40. In any case, we'll just, deal with that. So basically there's that table that let's see, sent you. I guess I don't have it pulled up, but I basically, it's a Word doc that shows you the outline. I've attached it to the email I'm sending to you. Sorry, this is so confusing, but I've attached it here. So this is online already, but here it tells you, it shows you the tables, so you can just fill those out. You don't have to recreate them. In fact, you don't even have to make a new document. All you need to do is to fill out these sections in here. It's already formatted with Palatino, 10-point font for the tables and single spaced, 11-point font Palatino double spaced, should be. Yep, for this written section. So you'll just, fill in the title that's reflecting what you learned from or the conclusions from the lab or the purpose of the lab. So not just passive transport, it would be something about, the investigating the effect of various glucose concentrations on the rate of transport across a selectively permeable membrane. I don't know, something like that. Then here's where your tables go. So you'll just take table 1, and this will go, just highlight it like that. This will go under here. Why aren't you pasting? Well, sometimes when I have trouble, pasting, you can do paste special sometimes. Let's see. I want any of that. I want to do this. There we go. Okay. Oh, sometimes it does this, so that's pain. So what I would do here is if it's messing up, I fill it in up here, with your colors that you got from the Benedict's test. Then what I'd actually do is I'd highlight it and copy it. So, you can do the Control C or Command C depending on your computer, or you can just do right click so you can copy. And then what I do actually is go here and then either right click, or on the PC it comes up when you click to paste it, or you can go up to the edit, paste special, and I'd paste it as a PDF. You won't be able to edit it anymore, but it's not going to get its format messed up. That should work. Let's see. Sorry, I do this all the time. There we go. And so if you fill it out up here, it'll have your data, your information, and then it'll put it in the table here. And you'll notice that it's going to stay together, and you can, resize it if you want. You always drag by the corners. And then if you move it, well, let me erase the messed up table. Yeah, if you move it, it's going to stay all together, and it's not going to get messed up. So anyway, and you'll have the title here. That'll be that. And you'll have this filled out. So I'll just erase that. And then you do the same for table 2. You, of course, want to fill in how many minutes you guys did. I think you did 28. Then figure 1, 2, and 3 are described in the post-lab instructions. So basically, it's going to be graphing this percent change in mass with a bar graph, and then graphing these masses over time with a line graph with multiple lines. And then number 3 is going to be graphing this here, which is the overall rate of diffusion. That you'll calculate. I'll show you in a minute. I think actually I'll show you on those recordings, but I'll just do it again. Okay, so basically what I've done here is I've taken the table and just pasted it into Excel, because that's what you need to do to make a graph, although I guess they do graphing from, yeah, you can do graphing from Word now. I guess you could just have your table and then do your insert line graph. I don't know what's going to happen here. I Well, that's sort of weird. I don't know. I just do this. So I copied it and put it over here. So the times on the top and then the things on the side, the groups. Like I said, I don't see your 0 time. I see 10, 16, 22, and 28. Unless this is 0. What the heck are these numbers? They're very large. Or maybe I didn't say that. I wrote it in the email. So I also have no idea what these numbers are over here. So just disregard those. Anyway, I can't tell where the zeros are, which is kind of a problem because all the tubing should be about the same. You can see it's starting to be really different already at 10 minutes because you've had a lot of water come in this case, most likely because the number should go up. Of course, you can't tell that because who knows what it started as. So maybe these numbers went down. So that's really problematic that you're missing the initial masses. So you'll have to talk about that in your analysis. The reason is because they all start about the same and then they change quite differently. So let's say they all started around 23. This one at 40% is already up to 28. You can see a lot of water has gone in very rapidly. Within 10 minutes, you've had that much increase in water inside, and that's what makes the mass increase. Versus something like the DH2O here, the control, which let's say it started at 23, has only gone up to 23.92. So the rate of water movement into the tubing is much slower than you would have at 40%, which is pretty much what you'd expect here. But without these numbers, it makes it difficult. Now you can see the changes between 10 and 16, 16 and 22, 22 and 28, but it's hard when you don't know when they started the same because it's not going to show you that initial movement. So what I would do is talk about that. This is what I would do. Talk about that you're missing the data and it makes it problematic to actually do the analysis. Let's see what the graph looks like. So to make the graph, and what I did here, you can see is I just put like the 5%, all of those into this column here. So double check me, but here's, 25, and then I put 26.26, 25.57, and then 25.40, and that's what I put across here. So double check those numbers. So then what you want to do for graphing is just to highlight the information that you want. I'm going to do two things. I'm going to copy this. Oops. So I'll just highlight it. Copy and paste. I'm going to delete the 0 column in this one because I don't want it to have a blank space, and we'll see what happens. So I'll highlight our data, then I'll go to insert, and it might look a little different on a PC, but pretty similar. And then I'll do my 2D line. Okay, so now you'll notice, get this marching ants. Okay, so you'll notice obviously the lines are super squishy. We'll change the axis to make it more reasonable to read. You'll also notice that the groups are here and the times are there. So that's backwards of what we want. We want the groups to be our lines. So what you do is you go to the chart design and then find switch row or column. So all Excels will have that, switch row or column. So now we see that the lines mean the groups and we see that the times are down here. Now another thing as well for this is that, let's see if I can format the axis. Because you did different time intervals, let's see what this does. Well, that seems messed up. Let's undo that. I don't want it to, it would be ideal if it didn't make these spaced out the same because that's not actually accurate as far as the times go. I didn't think about that when we were doing the changing it because we were running out of time. This doesn't look like it's changing. It's changing. Let's see what it looks like if I put 20. Nothing. Nothing. Okay, that's the tick marks. That doesn't apparently matter. Let's see what this does. So that's too big. Okay, sorry this is so long. Well, we might not be able to fix it. Let me pause this and see if I can figure it out. All right, I figured it out. So what I'm trying to do is, instead of spacing these evenly, which kind of gives you a distorted perspective because it's not as much time between 22 and 28 as it is between 10 and 16. Or it's more time. Oh no, it's 6 minutes each. The first interval is 10. Well, I guess it's okay. Anyway, if you want to make the bottom have different ones, you do a scatter plot instead. So when I graph it, when I choose this, instead of choosing the line graph, I do the insert and I choose the scatter plot with the lines. And that'll make this distributed, like all the numbers, and then it'll just put it at the right spot. So I guess you guys have 6 minutes in between each, so that's okay, except for the very first one. So yeah, I didn't actually calculate that. All right, so you're like, whatever, I can't see any information. So what we need to do is to adjust this vertical axis. So I just double click that, or you can go to like chart element and you go to axes, or let's see, more axis options. That'll give you things like this. So for the vertical axis is what you choose. The problem is that it's all this blank area. So what you want to do is to make it scale differently so you can see the difference between the lines. So what I'm going to do is I'm going to choose a number that seems to be the lowest number here. So I see like 23. So I'll choose minimum bounds. So here, instead of starting at 0, I'll start at 22. And then 32 is a reasonable number. We could even start at 23 if we wanted to, and then end at 31 or something. But yeah, you just don't want a lot of blank space because it makes it hard to see anything because the lines are close, but they're different once you look on a smaller scale. Okay, so that's one thing. So now you can actually see the DH2O, the 5%, 10%, 20%, 40%. You can see 40% increases the whole time. So it actually hasn't evened out yet, and so it's not at dynamic equilibrium. The water's still coming in. Whereas you'll see your 20% is pretty even. Looks like your 10% still increasing. Your 5%'s dropped some, but it's relatively even. And then the DH2O from basically 16 to 28 is pretty flat. It goes down a little bit, but that's just like kind of random fluctuation. So DH2O just shows you what the baseline line looks like. And like I said, because they all start in different things, it's sort of harder to interpret. So what do I do here? You need to change the chart title. You just double click on that, and then you make a chart title. I suggest how to do that in your instructions. You need to make labels here. So for all those, if you click on them, you might get this option here where, okay, I like to go chart design, and you can do here, and you can go to your axis titles. So I would do the vertical axis in this case, or you can double click on it, or you can right click on it and go to format axis. Sometimes that's also helpful. So you'll just get it in there, double click on your title, and you'll make sure you include units. So these are the masses, and we did it in grams. And then you'll need to make a title here. So again, I'll just do the chart title horizontal, and this is our time, and it's in minutes, MIN. These are already okay. I don't know, I like them on the side, but it doesn't totally matter. Legend options, I'll position it on the right. Okay. Like I said, it's okay either way. All right, so now we have that information, and then you just, like I said, fill this in. And so that is basically your chart that you're going, or your graph you'd interpret. That's figure 2. And what I would, if you have time to do what I would do, and then you could actually just comment on this and how it's hard to tell without the first number. Let's see what this looks like. I'm just going to put 23 in for all of them. I mean, it's not going to be exactly the same. Let's see what that looks like, just for the heck of it. I'm actually going to insert, and I'll do the scatter plot because the first interval is 10 minutes and the other ones are not. So this will make it more accurate here. Chart. Chart design. Add element. So we can change the axis. More axis options. There we go. So there's your axis option. So we can do our minimum again. This is our vertical axis. So let's just look. We said 22 last time. Nope, it's on the wrong axis. Undo that. Okay, click on this. There we go. There's our 22. All right, and then it goes up there. So I'd also probably do it where you don't have it smoothed. Oop. Oop. Get those options. Well, you should be able to, obviously you can change it, but it doesn't matter that much. The scaling does though. So now you can see here actually a better trend. Can you tell though, you know, how it goes up and it's really different for these? You can sort of see how much different it is. Anyway, so you could estimate something like that, and then it's not going to be totally accurate, but you could estimate something like this and then interpret that some. I'm okay with that as well. Okay, and then you'd put the axis labels and all that kind of stuff. So then what you need to do is calculate these things. And so basically this is, you can't just look at numbers because they all do start, they would start differently. So we can just look at this, they all start differently. So it's not accurate just to look at the total number difference, because if you're starting at 28 here to 30, that's 2, a number of 2, where 23 to 25 is 2. Like those are both about 2 grams, but it is not exactly. And you start by 25 and go to 26, and that's only 1, but you start at a different number. In any case, you have to do this percent change in mass. So to do that, to do a formula, you're just going to do equals. And the way this works is the final mass, so I'll just tell it to that box, minus the initial mass. I don't know, I guess we can't fake the data. Divided, so that's the initial mass we're actually looking at, divided by the final time, which is 28, minus the initial time, which is 10. That's how long it's been. And then you push enter. And we want to multiply by 100 to make percent. Enter. That tells you the change in mass for DH2O is 7.83%. Then what you can do actually is you want these numbers to change, the blue and the red box, but not the top boxes. So you can tell it not to change the boxes by putting $signs in there. So by doing that, and then we can drag it down. So you just take the corner, drag it down, and that's going to keep these changing to each new row, but that'll keep these numbers the same because every time it has the same time points. So this will show you the change, and see how messed up this is, because they're showing you that the change in mass of DH2O is way higher than all the rest of them. But if you were to instead use these numbers, then you get totally different readings. where the 5% is about the same as the DH2O, but everything else is really different. Let's just, I'm going to give you permission to do it that way. Just fake or not fake, you'll tell us, but just do the 23 because you're not going to be able to tell anything appropriate from the other ones. Okay, so that's the percent change in mass, and you'll compare those. And then when you graph that, basically all you'll need to do is copy this, just copy, and copy this next to it. Copy, okay, ooh, not negative. That's not good. Values only. It's really weird. Do 2 decimals. Okay, great. So then I'd highlight that, and you can do your insert, your line graph. And there you go, and you can see that. And you can actually see a trend. Whereas if you graph the other one, it's going to look really different. You'll do your lines again and all that stuff. Down here, you can actually erase the glucose because it's redundant. So what you'll actually do is on the axis, you'll say glucose concentration, and that would cover all these. Okay, and then you just label this axis glucose concentration, and that's what you need for this, and you need to change the title and all that stuff. In fact, actually, this axis is now your percent change in mass. That's not a good title. The title, it's reflecting how much water moves in. Okay, so that's that's graph 3, and graph 1, no, this is graph 1, and actually I asked you to do it in a bar graph, so all you have to do is click it again, mess that up, so change chart type. There's our column. All right, there you go. Same trend, but we're just showing it differently. Then the last one is your diffusion rate. So and that's what I just graphed. Oh, Lily, I'm so sorry. Hold on.